Hello students, welcome to Eduxcite classes. In today's session, we will start discussing the paper 1 topic 4, that is waves. This video is divided into two parts. In part 1 we will discuss from 4.1 to 4.3, and in the last part we will discuss 4.4 and 4.5. okay, so it's a request to all my students to please solve this worksheet before watching the video solution. The worksheet link you can find out in the description below, or you can scan the QR code. You can subscribe to my Telegram channel where you can find all my links to my video as well as the solved PDF of all my videos. Okay, so without wasting time, let us start with the 4.1 waves oscillation. So the very first question says, for a system executing SHM, the restoring force acting on the system is proportional to the. So we know that in any of those SHM, the force or the restoring force is proportional to the minus of displacement. Okay, or you can say A is proportional to minus omega square x. So if I multiply with mass, it will be nothing but the restoration force. Okay, so the force and displacement are directly proportional with a negative sign. It means the direction will be opposite. So displacement of the system from equilibrium. Question number 2, again the graph shows how the acceleration of 4 different particles varies with their displacement. Which of them execute the SHM? So we know that A is proportional to minus of x, so it is proportional with a negative sign, so it will be a negative slope, which is option B. Question number 3, the graph shows how the displacement varies with the time of an object undergoing SHM. So this is a displacement versus time graph given to us, and we are supposed to find out how the object acceleration varies with the time. Again, A is proportional to minus of x. So whenever this relationship is followed, you just have to know one thing. You have to reciprocal the graph. That means the positive part of the graph will be the negative and the negative one will be the positive. So just check among the given 4 options. This is not correct, and this is also not correct, because this part has to be the positive one. So only option D is suiting for the given. So you can see, yeah, the amplitude will be different because it's acceleration and displacement. So in that term also you can see this is the only graph which follows this relationship. Okay, so option D is the right answer. Now question number 4, the graph shows the displacement versus time graph for again a SHM. Always remember guys, whenever it is written simple harmonic motion, then only you can apply the equation that A is proportional to omega square x or minus of omega square. This is the condition for your SHM only. Now we are supposed to find out the correct diagram or the graph for the velocity versus time graph. Now we know a relation that velocity is nothing but the differentiation of displacement, or in other term, if the graph is given, I can say by finding out the slope I can find out the velocity. So the slope of displacement versus time graph gives me the velocity. So for the first part, from this point to this point, you see the displacement is decreasing. Okay, so it has a negative slope, so the velocity will start from negative. That one point we can consider from it, that the velocity will start from negative. Why from negative? The reason being because the slope is negative, the slope is you can say decreasing. So ds by dt is velocity, so velocity will start from negative. So this is incorrect, this is incorrect. So we have to discuss among B and C. Now you see at point 0, the slope is maximum in negative. Okay, at this position the slope is maximum. So at 0 the velocity will be maximum in negative. So at 0, at this position, the velocity has to be a negative maximum, which is option C only. So the correct option for question number 4 is C. Okay, I hope you got it. If you have any doubt, you can comment below. Now question number 5, there is a measurement of the height h of a sea level at different times t of a Bay of Fundy. Now you just have to find out which one is the approximate amplitude and the period of the tides. So these are the dots. You just draw a freehand sketch, so you will get an idea of a pattern of the wave forming. So I just joined the points from a freehand. You can use using a pencil in your examination. So you just see, we know that what is amplitude. Amplitude is the maximum displacement from the mean position. So if you see, the mean position is the halfway between the wave. So this is the complete wave. So halfway will be somewhere around this part. Okay, somewhere around this is from 13 and this is from 0. So something around 6.5 something. This will be the midpoint. So the amplitude will be this, which is 6.5 around. So option B and D are incorrect. Now amplitude is 6.5. Now what about the time period? So time period is the time taken for one complete oscillation. So here you see, this is one complete. So it started from this position and it come to this position. So this is something near about 12 hours. So the option C will be the right answer. Okay. Question number 6 now. Now this is the kinetic energy. This is very simple. Kinetic energy is always half mv square. This is the general formula. And in terms of SHM, you can say half m. V is nothing but omega square x square. So you see, it cannot, it is always a mass is always positive. Omega, any value of omega and x, if you do the square, so you will get always a positive value. Okay, so just looking at the graph, if you can see, the kinetic energy will never go in negative. So A is incorrect, B is incorrect. Now look at for how will you differentiate between C and D? So in one time period, okay, so if you see in one time period, how many times the velocity goes on maximum? So if you see any SHM, let us take an example of pendulum. So if it is goes from this position to this position, okay, so it becomes 0 at this point and 0. So you can say the kinetic energy becomes 0 in one time period. Okay, so kinetic energy becomes 0 twice in one time period. Okay, sorry. So in one time period, if you say it started from this position, so in one time period you can see it becomes 2 times 0. It is started from here, therefore it is 0. So one is here and one is at this position. So and here it is only there is no 0. So or you can say maximum also it goes to, because once returning to the mean position and while again going to the mean position. So option C is the right answer. Now for point 2, which is your traveling waves. Which of the following graph is the wavelength and amplitude? So again, it's quite easy. Wavelength is the one complete distance between one complete wave. So this is wavelength, yes. This is not, this is not. But amplitude is again from mean position to the maximum. So option D is the right answer. Now this is the definition. The speed of a wave is defined as the speed with which the energy transfer, guys. This is very important. This is the speed of transfer. When you write V equals to F lambda, this V is nothing but the speed at which the energy is being transferred by the wave, whether it is a transverse or longitudinal. Okay. Now question number 3. The graph P shows how the displacement varies with respect to time, and the graph Q shows how the displacement of the same wave varies along the distance. So which one of the following expression gives the speed of the wave? Now we know that speed of the wave is nothing but V equals to F lambda. Now F we know is 1 upon time period. So time period cannot be a single value, it has to be a range. So A and B are incorrect. Now C and D. So let us see, I can rewrite this equation as lambda upon time period. Okay, so lambda is with respect to distance. So lambda is from here to here. So x3 minus x1, this will be lambda. So and time period should be for the similarly the time period should be something around, there is no information given, t2 and t1 are only here. So t2 and t1 is the half time period. So can I divide by 2 on both numerator and denominator? So lambda by 2, if this is lambda, so lambda by 2 will be what? This distance, which is x, or this one. So x2 minus x1, I can write this as x2 minus x1 upon t2 minus t1. So the option C is the right answer. Okay. Question number 4 now. The diagram shows the variation of distance x along a wave with its displacement d. So this is the direction of wave travel, this is the distance, and this is the displacement. The period of the wave is t. Which one of the following diagram shows the displacement of the wave at t by 4? Now these are very common question from this topic. So the most easiest way is to extend the wave in the direction low. So let us say this wave is coming like this. So after time t by 4, so this is t by 4, this is t by 4. Okay, so this time period is t by 4 because 1/4 of the wave will move in 1/4 of the time. So you just move in the direction, so this whole wave will be shifted in this direction. So your wave will, the new wave after time t by 4 will be starting from, because this part of the wave will come in forward and whole wave will move in the direction of the wave travel. So you can see it will be somewhat like this. So which option is the best suitable one? You can check from the given option, which is option B. Okay, so you just shift the wave by t by 4 in the direction of the wave travel, you will get your answer. Now question number 5 is a direct question. Speed of the wave is v equals to f lambda. F is 1 upon time period. So it has answers are in centimeter per second only. So what we have to do is lambda is how much? Lambda is something around can you check here? This is 2.0. So lambda is 2 and time period frequency is given. Okay, so frequency directly is given, so no need to use the time period formula. So 2 into frequency is 10, which is 20 centimeter per second. Okay, option D is the right answer. Question number 6 now. A water wave ripple is traveling to the right. Okay, on the lake of a surface, the wave has a period t. The diagram below shows the surface of the lake at an instant of time. This is the piece of cork which is floating in the water in the position shown. Again, what is the correct position of the cork? T by 4. Now one thing you have to remember, guys, the particles do not, now this is a water surface wave, that is nothing but your transverse wave. Okay, now transverse wave, the particles do not move, they just move up and down. So option B and D will never be the answer. Now you have to think about option A and C. Now again in t by 4 in this direction, this part will be here. So the wave will start like this, like this. So option A is the right answer. You just have to think t by 4 later, this position of the wave will come to this part because it will move t by 4. This is t by 4. So the particle will be at position A. Now again this is similar question. This is again a transverse wave. The direction of the wave is from this point to this point, right to left. The point x and y are shown. X is at 0 displacement, y is at the minimum position of maximum displacement in the downward direction. Which of the following gives the subsequent direction of the motion of point x and y? Now just after this, what will be the subsequent motion? In which direction they will move? So this is the direction of wave travel, guys. Okay, now already this point y is at the bottom, so you can say it cannot go beyond bottom. This is the trough, the minimum displacement in the negative, or the maximum displacement in the opposite direction. So it has to move upward. So y is moving upward and it's a transverse wave, so it cannot move left and right. So answer will be upwards and downwards only, but we have to check which one will be upward and which one will be downward. So y is upward, that we know. So y is upward, so this is not an option, this is not an option. So B and D we have to select. Now if y is moving upward, definitely x has to move downward. Why? Because they are in anti-phase, or in other terms, if the object is moving in this direction. Okay, so you can see from this part also that the x point, so if this move the direction of the wave is from right to left, Okay, so the wave will be moving in which direction? You can draw it. The wave will be moving. So for example, the y will move upward. So let us say after this movement, this is moving. So 1 by 4 times. So this will be like this, somewhat like this. So x will be moving downward. So you can say, just a second, let me draw it. So if I say it has to, let us say from here I am starting. After this, what will happen? So let us say t by 4. So t by 4, it will be like this. It will be like this only. Somewhat. So x has to move downward. So option D is the right answer. Now again, question number 8. This is a very good equation. So the diagram shows the displacement position graph for a longitudinal wave of a spring. So a positive displacement denotes the coils of the spring are displaced to the right of the equilibrium position. Okay. At which position along the spring is the displacement of the two adjacent coil is maximum. Now for this I have taken one diagram here. Just look at this diagram. Now this is the normal spring. Let us say these are the coils of the spring. Okay. Now this is the wave diagram which is given in the question. You can see this is the diagram. Now just look at the position. This is again the displacement versus position only. Now you see at this point the displacement, these coils are from their mean position, they are very close. So as you move, this is the, you can say, the compression part, and there at this position this is the rear fraction, and again this is forming a compression. So this is one wave complete. So I can say this is compression, because we know that the wavelength in a this longitudinal wave is what? The distance between two compression or rear fraction. So let us say this is compression, this is compression. You can see. Okay. So these are the compression. So this is moving towards the left, and this is moving towards the right. So this is the positive, this is the negative. So this is one complete wave, this is compression, and in between compression there is a rear fraction, and at rear fraction only the coils will be very move apart. I repeat, this is compression, this is compression. So in between the compression at the half midway there is what? Rear fraction, and at rear fraction the coils will be the farthest apart. Okay, so this point will be your answer. So if you see for the question number 8, this B, option B is the right answer. Now question number 9, it's a direct question. Always remember the range for your visible, which starts from 400 nanometer to 700 nanometer. So as per the question, it will be 4 into 10 raised to power minus 7 meter, which is option B. And again, this is also you have to remember the order of the frequency around the visible. So gamma, X-rays, ultra, visible. So greater than the visible are your 3: gamma, X-ray, ultraviolet. Option check. Option A is the only suitable option. Okay. Now 4.3 wave characteristics. So this is a wavefront diagram is given to a circular wavefront. The frequency is 10 Hz and the one block denotes 1 centimeter. The speed of the wave, again V is equals to F lambda. So distance between the two wavefront is nothing but what? Your wavelength. So frequency is 10, wavelength is 1.5. The units are in centimeter only, so it will be 15 centimeter per second. Option C is the right answer. Question number 2, the path difference is lambda by 4. What will be the phase difference? So just remember the difference between one wavelength into in radians, that will be 2 pi. So difference is lambda by 4 divided by the complete lambda into 2 pi. So this will be 1 by 4 times of 2 pi, which is pi by 2. So answer C is the right answer. Question number 3. Two waves meet at a point in a space. Which of the following properties always add together? This is nothing but your displacement only. Direct question. Again, displacements are always added. So this is positive x1, this is minus x2. So the resultant wave at time t, which is equal to, if they are superimposing, so x1 plus of minus x2, that is x1 minus x2. Option B is the right answer. Question number 5. They superimpose again, the resultant pulse will be. Now always remember, the most easiest convenient way is, let us mark this 0 1 1 0 like the unit binary we solve. So when they superimpose, let us say, so this one and this one will get 2, okay, this one and this 0 will get you 1. So option B is the only answer. That's the simplest way. Now question number 6. They will go through and pass through it. It's a very easy question, direct question. You can watch various type of simulations are available. Okay, so option B. The two coherent sources. Now S1 and S2 are coherent. Coherent means they have the same frequency and they are an identical source, and they have constant phase difference or path difference. Which of the following best describe the intensity as P and Q? So when you say these two coherent sources, these are your nothing but your, either you can say these are the crest or the trough. So generally it is a crest. So when these two crest forms, you will find the intensity will be maximum at point P, because you can see these two are intersecting from the two sources. One is this and one is this. So at this point they will have a maximum intensity, and if you see at X only one, so and it is the midpoint between the other source. It is the midpoint of between the wavefront of the second source. So only if this is crest, so this will be trough and this is the crest of 1. So let us say this is the crest of P, then this at this position it will be the trough of the source. Let us say this is the crest of S1 and here it will be the trough of S2. So they will cancel out and you will get minimum. So P is maximum, Q is minimum, option A. I hope it is clear. If you have any doubt, you can just comment below. Now question number 8. The diagram shows the sunlight reflected from a lake surface. The reflected sunlight is plane polarized. So this is the surface which is plane polarized, and this is the plane polarized light. So if it is plane polarized, the plane of polarization of the reflected sunlight will be parallel to the lake surface, then only it will get plane polarized. Okay, this is the only condition of polarization. Now question number 9. An unpolarized light of intensity I0, let us say this is I0, incident on a polarizer. The transmitted light is then incident on a second polarizer. The axis of the second polarizer makes an angle of 60 degree to the axis of first polarizer. The cos 60 is 1 by 2. The intensity of the light transmitted through the second. So let us say this is I2, we have to find out. So this is I0. So after this, after passing through the first polarizer, the intensity, let us say I1. So I1 will be what? I0 by 2, taking the average. Always remember, if an unpolarized light is passing through the first polarizer, the intensity will be the half of the incident intensity. Now this I2 will be using the Malus law, I1 cos square theta. Now I1 is I0 by 2, cos theta is given 60, so 1 by 2 square, so this will be I0 by 8. Okay, so option D. It's a good question. Please remember this point. This is very important, that it becomes the average whenever it passes through the first, if it is an unpolarized light. Now question number 10. It is quite similar. This is a first polarizer, this is second polarizer, this is the intensity I. They both are having the same plane of polarization, parallel. So the incoming light on sheet 1 is unpolarized. So this is unpolarized. So let us say this is I0. So this will be I0 by 2 again. Okay, and the intensity of the light transmitted is I by sheet 2. To reduce the intensity by I by 2, which sheet must be rotated and through what angle? So there is no sense of rotating sheet 1, because if you rotate then also it will have I naught by 2 only, because this light is unpolarized. So always you will get I naught by 2 irrespective of its plane. So sheet to be rotated 1 only, there is no effect, 2 only, or 1 or 2, either of you rotate. So let us check what should be the angle. So to get at this as 1 by 2, that the I by 2, this has to be rotated in such a manner that the cos square theta has to be what? 1 by 2. So the theta should be what? Cos inverse, or you can say cos inverse of 1 by root 2. Say yes or no. Okay, cos inverse of 1 by root 2. So 1 by root 2 is this. 1 only is not possible, so only option C is the right answer. Okay, so this is the only option. So if you rotate 2 by this angle, you will get this I as I by 2. So I hope I have cleared all your doubts regarding the 4.1, 4.2 and 4.3. In the next class we will start, in the next video I will start with the 4.4. If you have any doubt, you just let me know. Okay, you can comment below. I will try my level best to reach you out as soon as possible. You can even download the PDF of this video. The link is given in the description, and even you can subscribe to my Telegram channel where you can find all my videos link as well as the PDF and the resource material which I generally update on regular intervals. Okay, thank you, keep learning.